Hello class. In our last week we have seen the colligative properties. The last colligative properties that we have seen was depression and freezing point, and we have seen the numerical as well. After that I have given you the solutions of numerical based on elevation in boiling point and depression in freezing point, and I hope that you all have gone through it and made a corrections. Okay, today now we are going to do the last colligative properties, that is osmotic pressure. Now let us try to understand what is this colligative properties. So before that we'll understand the term like osmosis. Osmosis. We are familiar with the term known as diffusion. So diffusion is the process in which the particles move from higher to lower concentration. And in case of osmosis, there is a movement of particles from low to higher concentration. So osmosis means the flow of solvent particles from the less concentrated solution to higher concentrated through semi-permeable membrane. So between the two solutions there will be a very thin membrane that we call a semi-permeable membrane, is called osmosis. Now say for example this is a simple diagram that we have drawn. In one side we have got less concentrated solution, and in the other side we have got higher concentrated solution, and in between that we have got a semi-permeable membrane through which we can only pass the particles. So according to osmosis, the particles of solvent will move from less concentrated solution to higher concentrated solution. Now if we increase the pressure on this side on higher concentration solution, say for example pi, so the pressure that is applied, if it is prevent the flow of solvent from lower to higher concentration, that pressure applied is called a osmotic pressure. So the minimum excess pressure which is required on the higher concentration solution side in order to prevent the flow of solvent particles through them is called through semi-permeable membrane is called osmotic pressure. So osmotic pressure is the minimum pressure which is required on the higher concentration solution side in order to prevent the flow of solvent particles through them through a semi-permeable membrane is called a osmotic pressure. Now we derive the equation for it. So before that we'll go for loss of osmotic pressure. When the solution is very dilute, the solid particles move like gaseous particles, or they show the same behavior as that of gases. So we apply gas laws in the osmotic pressure. So when the solution is very dilute, the solid particles move like gaseous particles. So we can apply the same gas laws in the osmotic pressure. Say for example Boyle's law. Boyle's law of gas, do you remember? So according to over here, it has been replaced by Boyle-Van't Hoff law. Temperature remaining constant, the osmotic pressure of a dilute solution is directly proportional to the concentration of the solution. That means mathematically osmotic pressure pi is directly proportional to concentration of the solution at constant temperature. So when you remove the proportional sign, we'll put constant, and so we can write pi by c is equal to constant, where as we know concentration is equal to 1 by volume, that is number of moles per volume. So pi we can write directly inversely proportional to volume. So when you just remove this proportional sign by constant, it becomes pi equals to constant by v. So when you just cross multiply, it becomes pi into v equals to constant, which is the Boyle's-Van't Hoff equation. And in Boyle's law gas equation we have got P into V, pressure into volume, equals to constant. It is the same. The only difference is the pressure is over here replaced by pi. Similarly, this is the first equation that we have derived. Next, Charles-Van't Hoff law. According to this, the statement states that concentration remaining constant, the osmotic pressure of a very dilute solution is directly proportional to absolute temperature. That means mathematically you can write pi proportional to T at constant concentration. So we can we can just change it by removing this proportional sign by putting constant. So it becomes pi by T equals to constant. This is the equation 2. Now in the third one we have got the combination of that two. Boyle-Van 't Hoff law and the Charles-Van 't Hoff law. So this is Van 't Hoff theory of dilute solution. So in Boyle-Van 't Hoff law, we have got this one expression pi proportional to concentration, and Charles-Van 't Hoff law, we have got the expression pi proportional to T. Now when you just combine these two, it becomes pi proportional to C and T. When you remove this proportional sign, we'll put constant, let that constant over here be R, where R is known as proportionally constant. It is also known as universal gas constant, whose value is taken as 0.0821 liter atmosphere per mole per Kelvin. Once again, this C concentration can be also written by N by V, that is number of moles per unit volume. So we'll just replace that in this equation. So it becomes pi equals to N by V into RT. So when you just cross multiply, it becomes pi into V equals to nRT. The above equation is known as Van 't Hoff equation. This equation is known as Van 't Hoff equation. We'll be doing the numerical based on this. Now there are two important terms that we need to understand the definitions. We can say isotonic solutions. So isotonic solution means solutions having same osmotic pressure at a particular temperature are called isotonic solutions. Say for example, if you have got two solutions and if their osmotic pressure are same, then we can call such type of solution as isotonic solution. Next topic we have got is reverse osmosis. So we came to know what is osmosis. So osmosis is the movement of solvent particles from lower to higher concentration through a semi-permeable membrane. Now let us see what is reverse osmosis. So when a pressure higher than the osmotic pressure is applied to the solution, the solvent from the solution starts flowing towards the pure solvent. So what will happen? So when the pressure is very high on the solution side, then the osmotic pressure, the solvent from the solution will start flowing towards the pure solvent. This process is called reverse osmosis. This process is very useful to get pure water from seawater, known as desalination of seawater. So from seawater, the salt and the pure water is separated by this reverse process.